Okay, projectile motion juggling that is, alright. So welcome to the next video. We're going to be looking at a simple case of projectile motion, that is balls just rolling off a horizontal surface such as a table. And what do we mean by independent motion? Well, remember that we said that projectiles have both a y component and an x component. So let's see if we can understand that concept a little bit more. So this is going to take multiple takes, but of course by the time you guys see it, hopefully it'll work the first go. Magic of Photoshop and video editing software. But I want to try and drop this ball, okay? And when I drop that ball, the time it takes for that ball to hit the ground should be the same should be the same time that if the ball was rolling that way. Because if it's independent, that is, if the y-axis is independent of the x-axis, since they're both starting at the same height and gravity is acting on both of them with the same degree of force, then they've got the same distance to fall. So it doesn't really matter whether it's going that way or whether it's being dropped, they should both hit the ground at the same time. So let's see if we can make that happen in reality. Okay, so here we go. Okay, so we've tried that, and you can see that there's two different pathways here. There's the pathway of it vertically dropping, and there's the pathway of it going in that direction there. So we're going horizontally. And you should be able to see that once we freeze them at the same time, that they're traveling vertically down at the same rate. So where this ball is meeting here, it's the same of where the ball over here is meeting. And then we go down, it's the same place. And then when they hit the bottom, it's the same place. So in other words, their vertical component is exactly the same. It doesn't matter whether we have a horizontal velocity going that way or whether we just drop it with no horizontal velocity. The y component forces are pulling both balls down at the same rate. They start at the same height, so therefore they have the same distance and acceleration. Okay. The key thing here is, though, you can see that if we look at the distance between each of the segments for the ball that's traveling horizontally, you can see that it has the same value. There is the same distance between each ball. What does that mean? Well, it means that it's covering the same distance in the same time, traveling at constant velocity. So that means there's no acceleration. So let's write those down. So with the x component, constant velocity. So whatever velocity you start off with here, it maintains that velocity for the whole duration of the trip. So if we started off a ball coming off this way, and we're getting rid of our original ones here, if we start with the ball coming off like that, and it's traveling in that direction at, let's say, 15 meters per second, so that's its initial velocity, then it's going to maintain that 15 meters per second for the entire trip. There's going to be no acceleration. Okay, in the y direction for this ball that's traveling in this direction here, so the ball that was rolling off, right, its y component is accelerating at minus 9.8 meters per second squared, and that's constant as well. The acceleration is constant due to gravity is constant, and its velocity at the beginning, though, so the acceleration is constant, but its velocity, if we were to draw a different color now, its velocity at initial velocity in the y direction, so we should put like a little x here, and its velocity in the y direction is 0. So the ball starting at the top is pretty much the same as if you were just to drop it. Right? Initial velocity y, gravity acting on it, minus 9.8 meters per second squared. So it doesn't matter whether it was traveling that way or not, its y components are exactly the same as if we were just to drop it from rest. And that's important to help you when you do some calculation. Its initial velocity in the x direction remains the constant and the same. So hopefully that little video there proves to you that we have the independent of x and y components of projectile motion. And a simple one is just going off a table and then falling onto a ground. And usual questions like this might be, if you roll a ball off a table with initial velocity of 15 meters per second, of course with this dripping like that, right? What range will it cover? and they probably will tell you the height, and from that you can work out the time of flight, and then you can work out the range. And we're going to go through some questions like that. So in the next series of videos, we're going to make some short little videos to show you some common examples that you might get. Okay, hope that makes sense to you.